Hi there, I'm Rakesh Murria, COO of Ascension. Recently, I gave a quick talk introducing AI, what it is, why it's happening now, what the big changes are, and what it might mean for investing. Very short, easy, snappy subject. A couple of people asked me to record it, and I'm going to do it using an allegory of self-driving cars or how that all works in comparison to different stages of AI, and a few internet memes just to spice it up a bit. To cover myself, please pause this video and read this disclaimer. So, what is AI? Since we've had computers, we've tried to do artificial intelligence. There is a reason it is called the Turing test, because it came up with Alan Turing in the 1950s. We tried it in lots of different ways, but really the first thing that we've tried to do was instruction-based artificial intelligence. So we create a set of rules and ask the computer to follow them. And when it comes to self-driving cars, for example, that's the same as basically giving somebody the manual for the Volvo and the highway code and saying, no, you can drive. And it turns out that's not the case for humans and not the case for computers either. However, in the 2000s, we started to learn from data using machine learning, a few breakthroughs happening there. And one of the big things that we learned was that we were able to train machines by providing massive data sets, so learning from data. And we used to label that data ourselves. So for example, here we have got on the right-hand side, the state-of-the-art machine vision test from 2015, which was computer tell the difference between a chihuahua and a cupcake. And the way that we helped a computer to do that was that we had people label thousands of bits of data saying this one's a dog, this one's a cupcake, and then the computer will be presented with the next one and see how it did. You can call that learning from data and supervised learning, sort of helping the computer learn. So bringing that back to this allegory of self-driving cars, you can imagine labeling lots of data, helping the cars understand what's around them, be able to sort of combine that with instructions of what to do when you see certain things. So that's where self-driving got to. You might think it looks like this, possibly. It certainly also looks like this, which is when you do these captcha forms, when you fill in a website form, etc., you're basically, helping Google self-driving cars with Waymo. Then in 2017, there was quite a massive breakthrough algorithmically in how to train AI models, and it was called the transformer, and it uses something called attention. So the paper was called Attention is All You Need. I'm not going to get into any of that, but this algorithmic breakthrough was really about how to train computers at scale. Lots of maths involved, but basically very simple in terms of understanding the concept. And then it was massively parallelizable, the same kind of compute that you use when you play a computer game. And that is why, incidentally, AI made NVIDIA extremely rich. This is where we got to in terms of AI systems, and now they were able to teach themselves. How does it work? Let me give you a sort of small example with the idea of how was the original ChatGPT that was released, how did that come about? Really, what you have is computer A and computer B, and computer A has a corpus of text. Let's say it's a book. It knows the entirety of that book. And then what it does is it sends some of that data to computer B with a blank in it. So basically it blanks out some of the data in the book and says, can you guess the word in between? And then computer B has to guess. And if it gets it right, it gets a biscuit. And if it gets it wrong, it gets, sorry, try again. And basically you do that over and over again, lots of times. That's a kind of basic answer. But what you do, just do it for the entire corpus of text on the internet, for example, and do it trillions of times. And just to give you an example, there are estimates that GPT-4, more recent version of ChatGPT, cost about $40 million to train in terms of the time and the compute that was involved in training that model. And repeating it trillions of times and sort of working out what's right and what's wrong, you end up with something, called emergent properties. In order to be able to answer those questions that you're asking, to fill in those blanks really accurately, the computer had to generate a world model, an underlying understanding of what is going on. One of the other things to mention here, by the way, is even with this self-supervised learning, there's a lot of something called reinforcement learning by human feedback. So when ChatGPT learned the internet as part of its training data, you could then ask it a question. You could ask it any question. So you could say something like, how do I make anthrax? And ChatGPT would go, oh, here you go. Here's the answer. So one of the big things that happens after you pre-train these models, i.e. do that big blankety blank process, is that you do this sort of reinforcement learning by human feedback. So there's a lot of people still involved in making AI work. Back to self-driving cars, do it via meme again, Galaxy Brain. Here are the instructions. Okay, here's machine vision plus instructions, still doing it. Now watch and learn. Avid readers of our newsletter will know that late last year, I got myself a Tesla. How do you if someone has a Tesla? Because they tell you within about 10 minutes. But the reason I got it was because I had seen that Tesla in early 2023 had basically thrown away about 300,000 lines of code, instruction based, like when you see this situation, do this thing, which is how self-driving for Tesla worked for many years. And they threw all away for a transformer based model of basically watch and learn. And they played millions of hours of video to the AI and basically said, now when you see the situation, what do you do? And they did the best self-driving demo I think they've ever done. Real people have got version 12 of self-driving in their hands. If you want to see demos of it, you can search it on YouTube. So hopefully that gives you like a sort of an overview of AI. I have tried to explain to you why we have got a shift in how things work in terms of this new architecture called the transformer, its ability to help computers learn by watching and doing rather than actually just being instructed. And therefore the speed of learning has massively improved. But what does it mean for now? Another lovely AI generated image on the left. But basically, if your AI specific feature is a tiny cherry on the cake, it's basically trying to replace a small part of a product. For example, I'm going to make your charts look prettier in Excel. I'm going to help you write some emails that look a bit nicer in Outlook or in Google or in Gmail. Probably not going to work in the long term. Yeah. If you're a glaring missing feature from an existing product set in AI, I would assume that Google and Microsoft are coming for you. However, if you've got unique and specialized data sets, if your business model is about completely replacing a tech stack rather than just adding a little cherry on the top, we think it's got much more potential going forwards. And in terms of models, well, as I mentioned, it's extremely expensive to train a model. Probably not going to, like someone like us is probably not going to invest in a foundation model unless there is another algorithmic breakthrough, state space models, Mamba, all this kind of stuff that is doing the rounds on Archive at the moment. Maybe it's interesting enough for you for us to take a look at that. If you know any R&D UK scientists that have come out with, some kind of state space model that is a lot more compute efficient, then yes, come have a chat. So I hope you've enjoyed that. If you would like to learn some more, you can scan this QR code and you can join one of the more detailed sessions that I run for people that are interested.